All right, let's take care of part C. We have the graph of r equals 1/2 plus cosine theta, and we're looking at the area between the loops. So to be able to see the loops to start with, why don't you plot r equals 1/2 plus cosine theta, and I'm sure that you set your calculator to polar form already, and see what kind of loops we are talking about. And I got a representative graph here. Okay, so there's the inner loop I can see, and there's the bigger loop. Okay, so bigger loop is in fact the graph right here. So let me just show you real quick here. So this is sort of like the outer loop, okay, and this is the inner loop. So the area being asked in this question is the one in between. So in between loops, oops, here we go. So we are being asked to calculate this area in between the loops, okay? So to achieve that, I need to know where I start on the graph and for what thetas would sweep the bounded region over there, the area. Okay, so for that reason, we're going to have like a little table here, as we always do. And again, I try to do it like by hand so that you can see what I'm doing, rather than just putting a table right there. Okay, so let's check. Let me just clean this up. Let's start with theta equals 0 to see where I'm going to start at. Okay. So for theta equals 0, we have, let's see, we have 1/2 plus cosine theta. So for theta equals 0, we're talking about 1/2 plus cosine 0. And that is 3/2 because cosine 0 is equal to 1. So on this ray here, starting from theta equals 0, right here, I'm going to be right at this point, okay? Right at this point. All right? So it's pretty good. That's where I start. So let's see which direction we go. Let's get another value here, like pi over 6. 1/2 plus cosine pi over 6. And this is 1/2 plus radical 3 over 2. And theta equals pi over 6 is right here. Okay. And that means on that line, I can see from the graph that I'm ending up here. So that should be the amount I walk on the array theta equals pi over 6 is just a numerical value for 1/2 plus radical 3 over 2. Okay, so it's good that I'm going in this direction. So I want to know what the half of the inner loop stands for. Okay, let's just keep going. Let's look at pi over 3. How about that? And this is 1/2 plus cosine pi over 3. Okay, cosine pi over 3 is 1/2, and this is equal to 1, just simply 1. Okay. At pi over 3, that is somewhere here, right here. And how about pi over 2? Let's quickly look at that. 1/2 plus cosine pi over 2, and cosine pi over 2 is 0, so this is 1/2, so we're right here. And I want to know when I'm going to come back here. Okay, when I'm going to come back here. So that's in fact us solving 1/2 plus cosine theta equals 0 type equation. So let's also look at that because we know that we're going in that direction. So why don't we continue with solving 1/2 plus cosine theta equals 0. So I will know exactly what theta corresponds to this point. So and cosine theta equals negative 1/2. And I should be in the second quadrant, and I should know where cosine theta takes the value of negative 1/2. So let's go back to the unit circle and look at cosine theta taking the value of negative 1/2 in the second quadrant. Here we go. I have 2 pi over 3, and the x-entry of that point is negative 1/2. And that's exactly where I should go. Here we go. So that means for 2 pi over 3, okay, which is 4 pi over 6, in fact. So somewhere here, so I hit this point, okay? So essentially, when you change theta all the way to 2 pi over 3, okay, all the way to 2 pi over 3, what I'm sweeping is this region. Okay, so the half of the outer loop, is constructed by looking at the area of that shaded region. Okay. So right now I know how to construct the area for the outer loop, like this area, and that includes some part of the inner loop, by the way. And that I'm going to write here. Let's go back here. So outer loop, at least half of that. I know how to find that. It's 1/2 0 to 2 pi over 3, 1/2 plus cosine theta quantity squared d theta. And if I want to even add, like if I want to find the whole thing here, so whole outer loop, so then I'm going to multiply it by 2. Right? The whole outer loop, including the inner one, you have to multiply that integral by 2. Okay? All right. So how about the inner loop? Because we have to subtract the inner loop from the outer loop, right? So that we can find the area in between the loops, right? So I have to go back here, and let me just erase this, and I'll come back. All right, so I know that at 2 pi over 3, we hit 0, so we're right here at 2 pi over 3. Okay, so what I want to know is how or when. So this is, in fact, 2 pi over 3. So we were going in this direction. So I want to know if I'm getting into the inner loop, if I continue or increasing the theta values here. So let's go with 5 pi over 6. Okay. 5 pi over 6 is somewhere here. Okay. Let's see where I'm going to end up. So we were looking at 1/2 plus cosine 5 pi over 6. Okay. So that's 1/2 minus radical 3 over 2 if you use the unit circle. And that's a negative number. That's good because on this ray here, I'm going to walk negative, and then that means I am having this point marked. So starting from here, I'm going in this direction on the inner loop. So I got into the inner loop. That's good. All right, so I want to know when I'm going to hit this point so that I can get the half of the inner loop covered. Okay. So why don't we go ahead and look at pi. And this is 1/2 plus cosine pi. And cosine pi is -1. So we get -1/2. That's awesome because when I'm on this ray, I'm walking 1/2 units on the other direction. So that means I'm going in this direction. There we go. I covered this point. So if I change theta, starting from, let's say, 2 pi over 3 to pi, okay, so going all the way here to here, right, all the way from theta equals 2 pi over 3 all the way to pi. So I am in the inner loop. That's awesome because if I think about this in the integration sense, right, in integration sense, to get the area of the half loop, all I'm going to do is just integrate. In the integration formula, I'm going to take the lower limit to be 2 pi over 3 and upper limit pi. So here we go. And I have, by the way, 2 parts of that to get the full inner loop. Okay, so I'm going to multiply everything by 2, and I'm going to keep integrating that from 2 pi over 3 to pi. Okay, so this is 1/2 plus cosine theta squared d theta. Okay, the rest is just handling this integral here. So let me just do one indefinite integral calculation here, and I'm going to use it for both integrals. Okay, so here we go. I have 1/2 plus cosine theta squared d theta. Let's expand this out. So this is 1/4 plus cosine theta plus cosine squared theta d theta, and we have to use the power reducing formula for cosine squared theta. Let's just do it real quick. 1/4 plus cosine theta plus cosine 2 theta plus 1 over 2. Okay, the theta. Let's integrate in one shot. So theta over 4 plus sine theta plus 1/4 sine 2 theta plus theta over 2 plus c. Okay? All right. I think we're done. What I'm going to do next is to copy this down right after the inner loop area calculation and outer loop. And we are going to sort of like integrate these two integrals by the antiderivative found in this blue ink, okay? All right, so I got them all copied here, and your task now is to evaluate these, okay, at the upper and lower limits and using fundamental theorem of calculus. I won't do that here, but I'm just going to write down the result here. So this is pi over 2 plus 3 radical 3 over 8, and this is pi over 4 minus pi over 4 minus 3 radical 3 divided by 8, okay? And now I'm going to go ahead and find the area in between the loops by subtracting the bottom one from the top one. All right, so this takes you to pi over 4 plus 3 radical 3 divided by 4. Okay? Woohoo! So that was a long question, but we are able to now we're able to find the area in between the loops here, and we got all this sorted out. All right. This is the end of this video. Thanks for watching. I'll see you in another video. Bye.